Hello, students. Again, we'll welcome back to topic of linear data structures. So, where we are discussing about data structures, there I stopped after the queue. So, after queue, so I stopped. I told about we'll talk about linked list after discussing about the what is called dynamic memory allocation. So now let us learn about linked list. Already we have understood about dynamic memory allocation. So now we'll discuss about linked list. So why this linked list concept has been introduced means let us will have some disadvantages of arrays. So arrays already we know it as a static data structures. So whenever we talk about static data structure means the size, the number of elements which we are going to store is always fixed, and also adding more elements and removing existing elements it becomes complicated because they're stored in consecutive memory location. During the compilation itself is the memory, the amount of memory to be needed has to be allocated. But what happens that makes a lot of problems because we do not know exactly the number of amount of memory location is required. So during the execution of the memory, during execution of programs, the memory, the amount of memory maybe varies. You take an example, so this academic we may be having only 60 students. So if I design the software to maintain only 60 students, for this academic it works exceedingly very well. So what happens when next year, so there may be decrease. So if it is we have only 30 means, so this program may not be efficient because other memory will be wasted. So if there's 100 students means this program may not work, this software will not work. So therefore that creates problems. So in those situation what happens, the software modification becomes difficult. So that if you use a dynamic memory allocation as and when it is required, so we can allocate memory without much difficult. So it is not fixed. So you have 30, you can use only 30 memory location. You want 100 means you can use 100 memory location instead of 60. This how it can be used to, it's advantages of dynamic memory allocation. So let us learn. So one of the uh, advantage of using arrays is that arrays disadvantages we are talking about. So the disadvantages of array is a static structures and therefore cannot be easily extended or reduced. Already I talked about extend, that is you cannot easily increase or you can reduce, is also difficult to fit the data set. So according to the requirement, exactly how many datas we have according to this data set, we cannot extend or we cannot reduce during. So during the insertion, the array elements are shifted. How normally it works means the whenever insertion is performed means the array elements are shifted into higher order memory locations, and already we discussed this with algorithm. And during the deletion, what happens means the elements are shifted to lower order memory location. This already we know about arrays. And in this chapters, we study another data structure called linked list that addresses these limitations of arrays. The linked list uses dynamic memory allocation. So whatever we have these drawbacks that will be overcome. So or we use this linked list that will eliminate or eradicate this drawback. How means we learn and we will able to understand linked list as a linear data structure and how this can be better than the linear data, that is what we call a static memory allocation. And using dynamic memory allocation, what are the advantages, you will automatically you will understand at the end of this chapter. So now let us learn what is a linked list. So you can see here linked list is a linear collection of data elements. So what does linked list means? It's a linear, the word linear you have to remember because it's a linear data structure, linear collection of data elements or items called nodes. So you can think what is node, we'll discuss. And the linear order or linear relation is maintained by means of pointers. So this order is given by means of pointers. What we are trying to do means, so we are trying to maintain this linear order using the pointers. So how means we'll able to linear order is given by means of pointers. So that is very important here. So what we have to understand is we have to understand here is how this why it is called as a linear data structure means. So this is a collection of, you can see in general you can call collection of nodes like this. This is one node, node 1, node 2, node 3, node 4, something like this. If you just you can imagine. So it's a node n1 like n2. This is the first node you think and this is the second node, collection of nodes. You can take here N3, and also we have a node 4. So it's a collection of elements. So you can see here 30, 20, 50. So that's we represented as a node. What is a node means? You can see here node as a two fields. One is called data field. You can see here data. Another is called link field. So address of the next node. So that is how it works. So we have a link. We'll discuss this one in detail and you'll understand this diagram. So what does a linked list means? It's a linear collection of data items or data elements called nodes, like this linear collection nodes, node 1, node 2, node 3. So they are collected, they are together, linear, one after the other. You can see the arrow here, they are one after the other. And the linear relation. So how they are linear one after the other means using the pointers. We have a pointer which contains address of this node, and it has the link field which contains the address of the next node, so that they are linear. So physically they are different locations, but they have used logical adjacency. So this may be at some address, this may be at some address, this may be at some address, this may be at some address. But what how do we say it's a linear? That's one after the other means not physically adjacent, but logically this contains address. This address may be 6550, this may be 1250, this may be 3546, some different numbers, different memory addresses. And this start always contains address of the first node, and the last node in the list will contains the null. That is the terminus, that is the end of the linked list. So it has no further nodes. This is where the list is ends. You can see that is what we have discussed in the above picture. Linked list with the 4 nodes N1, N2, N3, 4. So we can have 4 nodes, each node consisting of 2 parts. You can see here, so one is a data. This color you can notice here, this is one, and another that is called as the information part. So that is where we deal with the data. So the first part of the linked list is called data field. Normally we call it as a data field, and the next part of the node represents the next, that's a next pointer field. So where is the next node present? So it contains a link, that's address of the next node in the list, that contains address of the next node. So a pointer start. So this is, it's also a pointer which contains address of the first node in the list. So, and this sometimes this pointer is also known as head and start are same. So the link field of the last node you can see here. So this consisting of, let's say I mentioned here x, so it is actually consisting of null. So it is here x they have written, actually it is null. We don't have any value, so it is null. So the last field will be having the value null. So that indicates the end of the linked list. This is something about linked list. So it's a linear data structure because they are one after. So 30, the next element is 20, next element is 50, and one more element is 10. So after this it is stopped. But physically they may be at different location, but logically they are one after. That is, they may not be in consecutive memory location. That's why the linear order is given by means of pointers. So using these pointers, so we have a adjacency relationship. So that is how, that's why it is called as a linear data structures. So let us learn the types of linked list. There are basically 3 types of linked list. One is called single linked list, another is W linked list, and one more we have a circular linked list. We have learned already what is we studied is we have discussed is the example of single linked list or single linked list. We will discuss one by one. So what does the singly linked list means? A singly linked list consisting of 2 fields in each node. So that is, one is the data field, so another is the link field, as already we know. So the data field contains the data of that node, while, so what actually the data field means? It's obviously contains data like 30, 40, whatever number, character A, B, something. What we are going like 10.5, it's a float, or whatever data we are going to store. And the next field, we have a link field. What is this link field? Is nothing but a pointer that contains the address of the next node. So since there is only one link field, so in each, you can see there is only one link field in each node. It's also called as a singly linked list or single linked list. You can see here, you can say, take the diagram. You can, I think this is much clear. You can see here we have a start which contains address of this node. So in a linked list, the nodes need not necessarily represent set of consecutive memory location or contiguous memory location. So what they say is they are not physically adjacent. If you take this example, so I'll show you with some modification you can understand. So this may be, let us take addresses 605, some number I am writing, okay. This is address, need not be the correct address. So this is assume. So what about this one? This is 1040, some number, okay. And this may be something like 2566 maybe you can take. And what about this one? So this may be something like you can take 4300, no problem. So this, look at that, they are physically at different locations. So where this node is present at 1040, where this node is present it is 2566, where this node is present, what we are talking about, this is present at 430. So what is this start consisting means? Start always contains address of the first node. That is what is start means. So start is nothing but, now here you can see it's a pointer, so it has a value 6 5, what we just address takes some time, okay. Try to understand, it's quite not writing on the board, it's okay. So start 6550, it's also a pointer. Remember, everything what you are working is with the pointers, there is nothing else, all are pointers. That's why I talked about dynamic memory location, and also the importance of pointers here. So it is address. So what is this start means? It is now this line is established after getting this. So now start is pointing to this. And look at what is the link field of this data field. So we have a 50 here. So that's a data value. Here just this line. How this line is established means, so this 1040 will be here, okay. So it is 10 and then we have a 40. So now what happens? So this node contains the address of the next node. So now this has a meaning now. The link field always contains address of the next node. So now we can see here, what is the link field? 1040. What is the 1040? This is the address of this node. This is created at this. Physically they are not consecutive. Maybe at different places. You can see here 10 after 6540 it should be 6541. No, it is different. Dynamic memory allocation. So we may get anywhere, different places. But since we call it as a linear data structure, this is how, that's how, using by means of pointers. So now it contains. What about this now? So its addresses, this node addresses 2566. So it contains 2 and we will write 5. Okay. So then we have a 6 and also we have a 66. I think understood, you can understand. So then now we have a link. Similarly, this one we have a 4 and also some address 300 some address. And look at this. So this is null. So it has no value, no address. That is the end. So it is not connecting to anything else. So this is how technically you can, with the example you will understand. So this, whenever you access this field means it gives the address of the next node. So there we have a data. This also having two fields, data and link field. Always remember. So this is called a data field, first one, or info field, what we talk about. So this is data and everything like this data, and one more is a link field. So we have a here, so link field. So link field always gives the address of the next node, data field gives the data. So it can be any data, whatever interested you can store. So this also data, this link, this data, this link. So this is how a linear data structure is created in the memory. So using dynamic memory allocation. So we'll discuss that one. This is something about a linear data structure, which is a single linked list. In single linked list, the last node always contains null. So this is something, I think it's clear. So next we'll go with the circular. Another type of linked list is circular linked list. In a single list, a pointer is available to access all the succeeding nodes, but not preceding nodes. In a single linked list, you can see here. So always we have a pointer which gives the address of the next node. So we can traverse, that is we can visit the next node. So we cannot go for preceding, always it gives the succeeding. So from here to here you can go, okay, because it has address. Similarly from here to here you can go. So there is address. From here to here you can go. Always it gives the succeeding. From any node it gives the succeeding node. We cannot come to this node or we cannot get this node. So that is a single linked list. So when you take in a circular linked list, if the link field of the last node, if the link field of the last node contains the address of the first node, such linked list is called as a circular linked list. You can see here In a circular list, if the link field of the last node, so that's very important, link field of the last node contains address of the first node. You can see in the diagram. So such linked list is called circular linked list. In a circular linked list, it is possible to reach any node from any other node. How we will able to understand? You can see here. So this is actually a null. Because it consisting of address of the next node, so it becomes circular. So now starting with this node, you can go to this node, you can go to this node, you can go to this node, again you can go to this node, and again you can go. So from any node can be reached, but it is in a like unidirection. You can go in one way only. You cannot go back, but still you can reach this node by traversing like this. Go from this node to this node and this node to this node, again come back. You can, so that's what, in a circular linked list, it is possible to reach any node from any other node. So that is something about circular linked list. And we have one more is a W linked list or W linked list. So in a W linked list, what happens means it's a linked list which will be having three things, three fields. So that is, you can move in both direction. That is, you can go for forward, and also you can move backward. That is, you can, from starting with this node, you can go to the next node, or also you can go to the previous node. So that's why it's called doubly linked list. We have a two link field. That's why it's called doubly linked list. That is, in both direction you can traverse. You can traverse through the succeeding nodes, and from any node you can traverse in preceding as well. So that is something about W linked list. So in W linked list, it has three parts, as already we said. So we have a forward, that's a next node address, and back, it's a previous node address, and info means the data field. So it's nothing but node with the three fields. So one is a backward, so they have taken previous node, you can use any name you can use. It is a pointer which contains the address of the previous node. And what is forward means this is the next node. So what is address of the next node? So info means this is where we are going to keep data, and this contains address of the next node, this contains address of the previous. So when you have a W linked list, you can move to the next node or you can move to the previous node. That's the advantage. That's why it's called double-ended. So that's why W linked list. I think it's you have understood. So we'll take an example here. So in the first node, so if the back, so this is the first node, so it contains the null. So that indicates, that is how it is, that indicates, so this node is the first node in the W linked list. And also you can see the forward field as the null field. So then it is called, that is the last node in the list. You can see, you can notice here. So the backward field, that's a back, will have a null value. So this node becomes the first node, that is the beginning. We do not have any other node. And you can see here the last node in the list contains the forward pointer, forward field contains the null. So that is the last node in the W linked list. So this is how it works. So you can see here, you can go this way or also you can go this way. That is how it works. So this is the data, means it has got the next node address, and also it has got the previous node address. That's how we can traverse through. That is in both directions. That's why it's called double linked list, because we have two link fields. So this is something about the types of linked list, and let us learn about the operation which can be performed on a data structure. Already we know about linear data structures. What are the operations we can perform? Means traversing, insertion, deletion, searching, sorting, merging. So all the operation we can perform here. So this is one of important operations. So creating linked list. How do you create linked list? We discussed about all the nodes, how this node you are going to create, and how this relation between the different nodes are established. So that is what we are going to discuss. That's very important. So this creating a linked list, the function, if you are not understood, and this entire, the topic of linked list becomes very difficult. You will not able to understand. So this is the most important, and try to understand this carefully. You listen 2-3 times again. So it's very important, try to understand. So here let us learn about how this linked list, the node is created, and how the relation is established among the nodes. That's what we are going to discuss here. So linked list is a linear data structure which contains a group of nodes. So you can see a collection of nodes, you can call group of nodes. It's a sequentially arranged. That's very important. So that is, they are arranged because it's a linear data structure. So nodes are composed of two fields. That's data and address of the next node or reference of the next node. So these nodes are sequentially arranged. So that's why it's called as a linear data structure. A linked list, we start with the node and create nodes and link to the starting node in order to establish this linear relationship. That's sequentially. The pointer start contains the address of the first node. That's very important, address of the first node. And also next field of the last node contains the null. So last link field in the linked list must contain the address, that's a null. So we'll discuss how this will can be established. We can see here. So it is a programming code they have written, programming example. So we can define in two ways. So it's a structure with two members. You can see here this is structure, this is a declaration of structure. Again also this is one more method. So we define and declare. So both, I think last year you have studied about how structures can be defined. Structure can be defined in two ways. That's a defining structure followed by declaration. So this also you can define. So remember, all what we are working is with the pointers. That's is more important. You can see here. Now you can answer this. When you see this, you'll get some idea. If you are studying this last few classes, you'll answer this question. Okay, you can able to answer. You can see here the structure. We have defined a structure called node, which has a two field. You can see, I think you have understood. So we have a structure name node, which has two fields. One is two members, one is data, which is of integer type, and also we have one more is a star. You can see here it's a pointer. We have one more field or a member called link, which is a pointer type, and which type it is pointing to means node. What is node? It is same. I think what is this one? Can you guess what is this one definition? So it is a self-referential structure. I think most of you answered, you may be remembering. So if a structure contains a member which has address of the next node or a next member of the same type. So that is what we call as a self-referential structure. If a structure has a member field which will be pointing to another structure of the same type. So that is what we call as a self-referential structure. So linked list, so every node is nothing but a self-referential structure. This is how we are going to create. So whenever you create like this means, if you imagine, so this will be created like this. I think write it quite. Let me write. Okay. Let me take. You think like this. So this is. I'll write here. Okay. So you take like this. So this is a node in the memory which has some address. Okay. Okay. Probably bad in drawing. Okay, no problem. So let us. I think it's quite bit. Okay, regular class. It's okay. Here, no problem. I think you can understand. Okay, this is structure with the two members I've written. So this is as data. I'll write D only here. So because it's very difficult for me to write here data, and I'll write here L. So link. So this is where you are going to data field, and this is where you are going to store the pointers. So this node 1, how do you access this D means? So node 1 dot D, node 1 dot L. This is how you access the members. This is how it is created in the memory. It may be having some address. So any maybe 1, 2, something like this, 4, 0. So this is the address. And star node 1 contains this address. How do you access this member? Already we discussed node arrow, because when you work with the addresses, node arrow, node 1 arrow dot, that's we are star dot we are using already. No, we'll discuss that one. So node 1 arrow D, we are referring to this memory. Similarly, node 1 arrow L, that we are referring to this. Similarly, one more is created here, node 2, exactly similar, but with the different memory address. So this is just exactly similar. We have two field. One is data field, and another is a link field. So this is node 2. So if it is N1, it's node 1. This is node 2. So always it's maybe having some address. It's also something you can take 3, 4. Need not be adjacent. 1, 0, very simple. So what this node 2 consisting of this address 3410. What is node 1? Because it's a pointers data type of this type. So that's 124. This is just an example. To access these memory locations, we use arrow sign because the members of the structures are accessed using arrow. Actually membership operator. So here we are using pointers, means we use arrow symbol. That's already we discussed in the pointers. So you can see here the data is already the same thing they have explained. So here data is the information and the link is the link field. The link field contains a pointer variable that refers to the same node structure. That's very important. So similar type. So that's where you have to be careful. It's a self-referential structure. So such are called self-addressing pointer or self-referential structure. So there's a referring to itself, same pointers. So the above declaration creates two variable structures. Each structures will be taken as a node. So that's its linked list that contains two nodes. Another node cannot be inserted if not already declared. So also there are many cases when the memory needs to program only intermittently using a linear data structure. So I think it's not important. So already I've discussed about this. We'll understand, no problem. So just you go with this. So I think to perform this memory allocation, dynamic memory allocation, so we use the operator already. I don't want to waste much of time here. So new, this is how the new operator functions, this delete operator. So new followed by data type. So if it's an array means number of memory locations, more than one memory. So single, already we discussed this also we give an example, temporary variable and new. So it gives integer 5 consecutive memory location and we have the address of that 5 consecutive memory location and you can store. So that's how it works. Similarly, after its usage is over, it has to be delete pointer, delete array pointer also, the number of elements. This is a new and delete explanation. Already we know about those things. So we'll come back, we'll continue here. The first statement releases the memory of single linked list. That's how, delete operation. So let us learn about dynamic memory. That's very important here. This is what we are going to discuss is more important. So dynamically the memory space is allocated for the linked list using new operator. How we can perform means, so you can take here the data type. Already remember we have a structure, just it is part of this one already assuming, and this is the pointer name. So you need not be use new node, you can use P also. You can use any, no problem. So but they have to new node. This is how I'm going to create a new node. So we use the P is a one more pointer which creates of node type. So there is a space between and this there is a space, you can see here. So new is an operator, a node is structure type, and P is a pointer which contains address. So you can let me show you with the diagram. Let me write this one. Okay, this is okay. Now we are creating some memory, a structure node. As usual, it has a data field and also it has a link field. Okay, I think data. Okay, this may be some address. Okay, 4210 some address, and this two members. One is data field, link fields. What is this P now? What this P consisting of means, you can think now the P. What this one? So this address is copied to P. So what does P means now? After this statement is created in memory and it is initial by 4210. So now we can work with this. So data field of P. You can use a P arrow that will give this memory. P arrow will give this one. So this is how this node dynamically creates a memory and that address is handed over to the P. So now P contains address this one. So once it has address, we know how to operate using the address. Using the address, we can operate here. The same thing, using the same address, we can access this also. So that is what a P here, the pointer. So it has two member structure. So structure type node will be created like this and it is handed over to the P. That new operator does like this. So this is simple programming showing creating a linked list and appending the nodes into the linked list. So how we can do, we have gone with algorithm, I think no problem. We'll learn about how to create. Already I've explained how it is created. Let us go with the programming. The same thing we'll be discussing. And you can see here we are using, I think program with you are familiar. So I'm writing a program class and objects. You are familiar with the classes and objects. So here I am taking a linked list. So linked list, you not we take linked list, you can use also LL, no problem. So it's a class name, linked list. So linked list means I have to use linked list, then only it works. No, you can use any class name. So it's a valid identifier. Even I use most of my, when I do the programs, I may using LL, linked list, or you can use any name, no problem, the class name. So I have creating a class called linked list, which has a private member, only one private member, which is a pointer to a node type. You can see here only we have a start and preceded by this star. So what is this? This whole thing is a structure, and also we have a pointer for that structure. Just we have only address here, only one variable start. That is, it can get the address of this one. You create any memory in the future, and that is should be of this type node, and it can receive the address of this type. So that is what the start here. So if you understand simple way of means, so you can create like this anything anywhere in the memory, okay, and it has some address. So that address can be copied to start. So start can contain like this type of storage memory. The start can going to store the address. So if it is 1 to something like 00 means it's address. In the future, you can store start of this type, okay, which has a data field, which has a link field. The start can contain the address like this. So that is what just for here, just we declared. We have not created this one, just we declared. I think this is not allocated. When you use a new operator, it's allocated. That's why I'll delete this one. You can. This is only understanding purpose I wrote. So in the future, it can store the address of this type of memory. Okay, so that is a pointer. Now we are declared. So now let us discuss about other functions. So this is only member, pointer, data member, and we have three member functions. So one is the constructor, which has the same name as that of the class, and also used to print the elements and also used to append. So it's inserting an element into the linked list at the end, adds a new node at the end of the linked list. So count is a function which is used to count how many elements are there, how many nodes are there in the list. And this is the end of the class. So there are three, 1, 2, 3, 4, 4 member functions, linked list, one constructor, one printing the nodes of the linked list, the contents of the nodes, and one more is appending, adding the element into the, one more node into the linked list at the end, and one more is counting how many is there. So what is we are trying to assign here is, I'm taking very simple one. So before I start, so we have to initialize. So whenever we use object and class we use means we use a special member function, that's a constructor. I think you already known about constructors. So now because start is going to store the address of variables, therefore I am going to store null presently. So whenever an object is created of linked list, whenever you create an object means automatically the start becomes null. That indicates it is not pointing to any of the node in the linked list. That is, you are not created. That's why to begin with, the constructor is, that is a start. Normally we are using some variable, sum means sum is equal to 0 because it should not be get a plus s is equal to a plus b we are writing, where a is 10, b is 20. So therefore, because it stores 10 and 20, we store 0, nothing will happen. So similarly, because we are using nodes, linked list, the pointers, addresses, so therefore to begin with, I'll put start is equal to null. That indicates right now start is not pointing to anything. So whenever you create new node, get the address and make the pointer to point to that node. So that is why we use this one, start is equal to null. And next, let us learn how to print the contents of the linked list. So this is one, we have to check this, the list is empty or not. How do you check the list is empty? Means when start point is null, you can see here null, there is nothing exist. So therefore, you can say linked list is empty. So that's quit, come back, exit, return. Otherwise, what we have to do means we have to traverse through the linked list. Traversing means visiting each node and performing some operation and go to the next node. So that's what we are trying to do here. So let us, we'll take some 3 nodes. You can follow. Okay. So this is the first node and this is second node. For just I'm writing, you can understand. And this is a one more node. Okay. For understanding, I wrote traversing means, So we have to visit from this pointer already established. That is, we know the address, and this is as the address, and it has a null, so there is nothing. And maybe we have some 10 value data, some data 20, and maybe 30, anything you can, you can use any numbers. Okay, so what is this one? Start contains address. So here we have a start. The start contains address of this node. Through this start pointers, now what we do, that is how traversing means visiting this node and visiting this node and visiting this node, visiting exactly each node and performing some operation. That is what traversing through the linked list. Now I have to traverse because I want to display all the elements, means first 10 has to be displayed, and then we have to go to the next node, 20 has to be displayed, and 30 has to be displayed, and null means we stop. So I think you can see here. So traverse, visit each node till you reach the link field is null. So once the link field is null, we have to stop. That's what we are using. So we created one more pointer p. So using the p, we are modifying. So p is equal to start. If p is 1000 means the same number is copied to, because the start value should not be changed. So therefore I took one more pointer variable. The start is pointing to this and p is also pointing to this. Now we have two pointers, p and start, both are pointing to the first node of the linked list. So while p not equal to null, I think you can see here p is not equal to null. No, it is maybe some address, 1550 means that address, not null, so display the space and p arrow data. P arrow data means this one, so 10 is displayed on the screen, very simple. Looks like, okay, 10. So this 10 is displayed. How means p arrow data, using pointers, objects. I think you already have explained this one. Next what I did, so I have to go to the next node, so I'll update the value of p. So what was p is pointing to this now. So link of p. So link of p means, let us assume it is some address 1, 2, 3. Right, okay, it's 1, 2, 3. And this is some address, I'll write 40. Simply I'll write, so this has a 40. Link field as a 40. This has 1, 2, 3. And this itself is maybe 404 example. So beginnings, start is also 404 and p is also 404. So 404 arrow data means it will give the value stored at address. Similarly, 404 link means, so we have a 123. Now p becomes, right now the p value now changes to, which was 404, now p value is 1, 2, 3 for understanding I'm writing, okay. So this 1, 2, 3. So what is p not equal to null? 1, 2, 3 not equal to null? Yes, repeat. Now what we do, we display. So p is here. So link p arrow data. So this p is 1, 2, 3 now. P arrow data means 20. What we did is see out. So it is displayed. So 20 is displayed on the screen. So next what happens, p is equal to p dot link. So what is this 1, 2, 3 p? Dot link means we have a 40. So this automatically now it becomes 40. So now let me, what is a p means 40. 40 is not equal to null. Yes, it is not equal to null. Repeat again. So give some space and display what is the data at 40. So data at 40 address is, we have the value 30. 30 is displayed. The link field now, what is the link field here? Null. So what happens to p? So p becomes, I think you can understand now what is the link field of 40 is p. So that is, we have a value which is null. So we have null. Can understand. So null not equal to null, false. So stop this one. So what it does means, it is traversed through the linked list and displayed 10, 20, 30. This is how we are going to repeat. So traversing, whenever it comes to means start from the first node, take pointer and visit node exactly by updating the pointers using the addresses, move to this. Update, move to this. That's how one more pointer I took, I moved this. I think you understood this one. So now let us learn how to insert an element into the linked list. How do you add a node into the linked list? So this function append accept an argument. That's where we are going to insert an element means. So we use num. So it's from the function. Whenever this function append is called, you have to supply some value. Here I'm using this is a pointer. New node is not a. You have to be careful. Like p, this new node, this entire thing is just a pointer name. That's very important. This is pointer name, and this is new space is different. So this is function new, and this is a pointer. Can I use a p or p something like so? This is a pointer, and this field. I think you understood. This is the value you are going to store. This is the link. So this is how we are going to create. So if you want to insert a new node means, so then first we have to create a linked list. That is, we have to create a node. How do you create node means we use a new operator. So it is created, let us like this and this one. So here this is created with some address, and now that address data, we are supplying the data which is received num. So if I received 40 means that 4 means, so 4 will be like this, 40 will be copied. That num, whatever you send num, that num is copied. This is how you can see here in diagram. You can see it's clear, I think. Oh, sorry. So this is how this number, that number is passed. So it becomes like 40. What is this? The newly created, and it must have the link field null. So this has to be attached. So this is a one more node we created, and this has to be connected. This is how just adding, appending. So it has got some address, and this has to be connected. So where do you connect means where this has to be, it has some address 1, 2, 3, 4 example. So this address has to be linked. So where do you link? That is what we have to check now. So if start equals null means there is no node, so this becomes the first node. So where is this 1, 2, 3, 4? It is new node address. So that's what I did. If it is null, start is equal to new node. So it is copied, and this is inserted as the first node. This is how it works. So created and inserted as the first node. Otherwise, we have to traverse through the existing nodes. Already you can see traverse through. Here what happens means instead of taking just a p, I took link field of each node. Till we reach the link field null, till that you traverse. So after reaching the link field null, so there you copy that address. I think you are, if you take the same example here, so let me write, no problem, once again you will understand. Okay, so this is first node on the previous example, this is the second node, already they have a relation. Okay, so this is a third node example. I think imagine, I think this is something like 10, this is 20 already we discussed, and this is 30. I think this is very important. This link field is null. So till this, so this is not null, it contains address. This is not null, this contains address, but this contains null. So we, p is equal to start. As usual, we create p start. This linked is identified by start. Okay, and then we go with start and p. So p is both are same previous example. We traverse not null, this link field. We are concentrating only on the link field, not data field. So link of start now. This is not null. We increase, go to the next node, copy the address. Again link field, not null. We go to the next here. Link field, yes, null. So stop. So we found this, and previously what we created, where is that 1, 2, 3, 4? That is in the new node. So in that place, link field, we knew. So now it is connected. And okay, so it has 40 already, and it has a null here. So this becomes a part of the list. So this is how it is connected. This is how we insert append at the end of the linked list. So this is how we are going to add the node into the linked list. And counting how many nodes are there means just traversing like this, we increasing every time some C++. So you can see here, how do you try one more function is a count. So traversing the pointer, start with p is equal to start, p not equal to null, p is equal to p dot link till C++. This is very simple one. First node not equal to null, again get updated. Same thing. So see, it's not difficult at all. Okay. And here we come to the main program. So we create an object here, because what we are going to create is a pointer. It's very important here. I'm creating an object. It's a pointer class. Already we discussed this. Linked list is also pointer. Here I'm going to create a memory space for new object. It's a class name we have to write. This is not a function, so this is wrong actually. We are not supposed to take this one, this printing mistake. So it is, we are creating a class type of dynamic memory. What we discussed, like this whole thing will be there. We have member functions and member start. Here we have a start pointer. Okay, and then we have 4 member function, constructor, and then print, append, and then count. So this handover, like for that amount of memory is handover, and this is identified by OB. You can see this also pointer. It returns the address, and there we have the functions. So object.print means it calls this function, print function. Object.append means it calls the function. So here you are sending, this takes the address and perform. Again print, it will print. Again call the function count. So it is repeating. That's functioning. So when you do practically, you'll understand. Again you call the function. You can call the function enum. Now with the 200. When you do this first time print, it display the message queue is empty. Second time what happens? It creates a node like this example. You can see that is created, appended, so 100. So displays like this. The linked list contains 100. Next what happens? It creates one more, that is 200, and again it counts also 1 will display. So print means it displays 200. This is output on the screen. First you will get 100 and you will get 200, and count means this time it will display the number of nodes in the list is 2. Again append 3, so one more created. This is happening inside. I'm showing here. So 300, it is displayed. When second function we are called print here, this will be 300. Count 1, 2, 3, the list consisting of 3. So stop over. This could also be write it in a function as well. You can call any number of like stack, queue we did, you can do it. So this is a simple one. How it works you have understood. Okay, so let us learn next classes the what we call the algorithms, how it works, we'll learn, okay? We'll continue in the next class. Okay. It's very important, try to understand. If I have any doubts, let me know. Okay.